Welcome to this channel. In this video, we will discuss about the harmonic oscillator in quantum mechanics. First of all, the Hamiltonian of particle of mass m with angular frequency under the influence of one-dimensional harmonic potential is H is equal to P square over 2m plus 1 by 2 m omega square x square. This is equation number 1, where P and X and H are operators. Now we will introduce two non-Hermitian operator, which is annihilation operator A is equal to 1 over square root 2 h cut m omega multiplied by m omega x plus iota p. This is equation number 2. And creation operator A dagger is equal to 1 over square root 2 h cut m omega multiplied by m omega x minus iota p. This is equation number 2. Annihilation and creation operator satisfy following commutation relation, which is A and A is equal to 0, and commutator of A dagger with A dagger is also equal to 0, and commutation relation of A and A dagger is equal to 1. Now we will prove commutation relation of A and A dagger, which is equal to 1. Consider commutator of A and A dagger, which is equal to A dagger minus A dagger A. Now put the value of A and A dagger. So this become 1 over 2 h cut omega m multiplied by m omega x plus iota p multiplied by m omega x minus iota p minus m omega x minus iota p multiplied by m omega x plus iota p. Now we will multiply these two terms and these two terms. So this is equal to 1 over 2 h cut m omega multiplied by m square omega square x square plus p square minus iota m omega xp plus iota m omega px minus m square omega square x square minus p square minus iota m omega xp plus iota m omega px. So this term and this term is cancel out, and so this become 1 over 2 h cut m omega multiplied by 2 iota m omega px minus 2 iota m omega xp. Now we'll take common 2 iota m omega. So this become 2 iota m omega over 2 h cut m omega multiplied by px minus xp. Since we know commutator of x and p, which is equal to xp minus px is equal to iota h cut, and commutator of p and x is equal to minus iota h cut. So this is the commutator of p and x. So this is equal to iota over h cut commutator of p and x, which is equal to iota over h cut multiplied by minus iota h cut, which is equal to minus iota square, which is equal to 1. So commutator of a and a dagger is equal to 1. Now define an operator n which is equal to a dagger multiplied by a. Now put the value of a and a dagger. So this is equal to 1 over 2 h cut m omega multiplied by m omega x minus iota p multiplied by m omega x plus iota p. So this is equal to 1 over 2 h cut m omega multiplied by m square omega square x square plus p square minus iota m omega px plus iota m omega xp. Which is equal to 1 over 2 h cut m omega multiplied by m square omega square x square plus p square plus iota m omega xp minus px. This is again equal to commutator of x and p, which is equal to iota h cut. So this term is equal to 1 over 2 h cut m omega multiplied by m square omega square x square plus p square plus iota m omega multiplied by iota h cut, which is equal to 1 over 2 h cut m omega multiplied by m square omega square x square plus p square minus m omega h cut, which is equal to m omega x square over 2 h cut plus p square over 2 h cut m omega minus 1 over 2. Now multiply by h cut omega. So this become n h cut omega is equal to a dagger a h cut omega is equal to 1 over 2 m omega square x square plus p square over 2m minus 1 over 2 h cut omega, which is equal to a dagger a plus 1 over 2 multiplied by h cut is equal to p square over 2m plus 1 over 2 m omega square x square, and this is equal to Hamiltonian. Let phi of n be non-zero eigenfunction of operator n with eigenvalues n. So when n operator act on state phi of n, it gives n of phi of n. Similarly, when h act on state phi of n, it gives e of phi of n, where E is the energy. So when H act on this state, H of phi of n is equal to n plus 1 over 2 H cut omega phi of n, and so this gives us E of phi of n is equal to, and when n act on phi of n, this gives us n plus 1 over 2 h cut omega phi of n. So it implies that energy is equal to n plus 1 over 2 h cut omega. This is the energy of harmonic oscillator. And n operator is equal to a dagger a, and n obey the following commutation relation. Commutator of n and a is equal to minus a, and commutator of n and a dagger is equal to a dagger. So first of all, we will prove commutator of n and a dagger, and n is equal to a dagger a. So this becomes commutator of a dagger a and a. Now we will use property commutator of a, b and c is equal to a's commutator of a and c multiplied by b plus a multiplied by commutator of b and c. So this term is equal to a dagger commutator of a dagger and a multiplied by a plus a dagger commutator of a and a, and commutator of a with a is equal to 0, and commutator of a and a dagger is equal to 1, and commutator of a dagger and a is equal to minus 1. So this is equal to minus a. Since a is annihilation operator. When A acts on any state n, it lowers the state by n minus 1. This is equation number 2. Now we'll find the value of C. Take complex conjugate of equation A. Of equation 2. So this becomes n A dagger is equal to n minus 1 C star. This is equation number 3. Take inner product of equation 2 and 3. So this becomes n A dagger A n is equal to n minus 1 C star C n minus 1. Since C star C is equal to C square and it is constant, so we will take outside. So this is equal to C square n minus 1 n minus 1. Since n is equal to A dagger A, so this term is equal to n operator n. When n operator act on any state, it gives us n eigenvalue. So this is equal to n is equal to C square n minus 1 n minus 1. Since phi of n, phi of m is equal to 1 when n is equal to m. So this term is equal to 1 and this term is also equal to 1. So C square is equal to n and C is equal to square root n. So put the value of C in equation 2. A, when A act on any state n, it is equal to square root n minus 1. Since A dagger is creation operator, it raises the state by 1. Since A dagger when act on state n, it raises the state by n plus 1. This is equation number 4. Now we'll find the value of B. Take complex conjugate of equation 4. So this becomes n A is equal to n plus 1 B star. This is equation number 5. Take inner product of equation 4 and 5. So this becomes n A dagger n is equal to n plus 1 B star B n plus 1 and B star B is equal to B square. Since B square is constant, so we will take outside. So this becomes B square n plus 1 n plus 1. Since inner product of state n and m is equal to 1 when n is equal to m. So this term is equal to 1. This become b square. Since commutator of A and A dagger is equal to A dagger minus A dagger A is equal to 1. So A dagger is equal to 1 plus A dagger A, and A dagger A is equal to n. So this become 1 plus n operator. So this term is equal to n 1 plus n operator n. When n operator act on n, it give n eigenvalues. So this term is equal to n plus 1 n. So n plus 1 is constant, so we will take outside. So this become n plus 1 inner product of n and n. And this term is equal to 1. So b square is equal to n plus 1. And b is equal to square root n plus 1. Put value of b in equation 4. So when A dagger act on state n, it gave us square root n plus 1 eigenvalue with rising state by 1. Since A act on n state n, it give eigenvalue square root n with lower state by n minus 1. And A dagger when act on state n, it give eigenvalue n plus 1 with state n plus 1. So if we have state zero, so A act on 0 give us 0. When A dagger act on state 0, it give us 1 with state 1. When A dagger square act on state 0, this is equal to A dagger A 1 state, which is equal to square root 2 state 2. Similarly, when A dagger cube act on state 0, which is equal to A dagger square state 1, which is equal to square root 2 A dagger state 2, which is equal to square root 2 square root 3 state 3. For arbitrary and this pattern yield when A dagger act on state 0 n time, it give us square root 1 square root 2 square root 3 square root 4 so on square root n with state n, and this is equal to square root 1 dot 2 dot 3 dot 4 so on dot n with state n, and this term is equal to n factorial. So this becomes square root n factorial with state n, and state n is equal to A dagger raised to power n with state 0 over square root n factorial.